It's common knowledge that the Next Generation Air Transportation System, or NextGen, aims to reduce delays while increasing capacity in the national airspace system. But every bit as important is the potential NextGen holds to significantly reduce fuel consumption and thereby carbon emissions, protecting both the environment and the financial health of the airline industry. To help make that point, since the beginning of June, the FAA has been participating in a series of operational trials aimed at demonstrating the fuel-saving potential of route optimization over the Atlantic Ocean, coupled with tailored arrivals into Miami International Airport. The trials are being conducted under the auspices of AIR, the Atlantic Interoperability Initiative to Reduce Emissions, a program aimed at exploring ways to reduce aviation's global carbon footprint. AIR is a joint initiative of the FAA and SESAR, the Single European Skies Air Traffic Management Research Program, Europe's NextGen equivalent. Participating in the almost daily flight trials are American Airlines, Air France, Lufthansa, Air Europa, and TAP Portugal. The first portion of the trial begins as the aircraft is over the Atlantic Ocean. As the progress of the flight is monitored by the airline's operations center, certain conditions such as shifting winds could create an opportunity for time and fuel savings by adjusting the flight's trajectory. Thanks to the recent introduction of new techniques at New York Center, coupled with the center's Ocean 21 automation system, which tracks all oceanic traffic, these sorts of dynamic optimizations can now be realized almost instantaneously. John Azzarone, Oceanic Operations Manager at New York Center, says the process begins when the flight crew sends a revised trajectory clearance request via text message using a text-based application known as Controller Pilot Data Link Communications.
Our controller will probe that for any conflicts up to 2 hours along that trajectory, four-dimensionally. And if there are no conflicts, we'll uplink an approved message. The crew will insert that into their FMS, and they will make their course correction, optimizing their routes. The entire process, including the conflict probe, can take less than a minute. And so far, says Azzarone, these optimizations have been hitting the mark. We've had a number of these demonstrations over the last month or so, and it's resulted in significant cost savings, both in fuel and carbon emissions to the carriers.
Azzarone says this functionality is and will continue to be available to properly equipped aircraft even after the trial period concludes. The second component of the trial involves the issuance of tailored arrival clearances to aircraft bound for Miami International Airport. Tailored arrivals are customized approaches that take advantage of what's called an optimum profile descent. Optimum profile descents allow an aircraft to glide on idle thrust from the top of the descent all the way down to the runway. This type of approach burns significantly less fuel than the traditional step-down approach, which requires aircraft to level off at several points during the course of the descent. Again, Azzarone says the process begins when the aircraft transmits a data link request for a tailored arrival clearance from New York Center.
We have established a procedure where we've asked the crews to make their request at least 45 minutes prior to crossing the New York Center and Miami Center boundary. That gives us enough time to actually do all the necessary coordination, gives Miami Center enough time to make sure that they can accommodate it. They need to, of course, coordinate with Miami Approach Control to make sure the conditions are right for accepting and approving the tailored arrival.
Once the aircraft crosses the boundary between New York and Miami Centers at an agreed-upon time and altitude, it's picked up by Miami Centers radar and handed off to the Miami TRACON, which uses voice communication to authorize the execution of the tailored arrival. Russ Marino is the support manager for plans and procedures at the Miami Combined Tower and TRACON.
Miami Tower assumes control of the tailored arrival when the aircraft is approximately 40 miles northeast of the airport. From then on, the controller has to decide whether the aircraft will fit into the arrival flow or what it takes to make that aircraft fit into the conventional arrival flow at Miami.
Any number of factors could cause the flight to have to power up and abandon the tailored arrival, including weather and traffic flows. Marino says he's been pleasantly surprised to see that, so far, roughly 20% of the aircraft involved in the trials have been able to stick with the tailored arrival all the way down to the runway. An additional 60% have completed at least a portion of the procedure. Bobby Green, frontline manager at Miami Center, says the credit for that success lies squarely with the controllers.
The controllers are the ones who make it work. They're the ones that make the call. This is a completely different concept for them. And they have been phenomenal on really making this successful so far.
Even for those flights that have had to deviate, the fuel savings have been measurable. That bodes well for the future of tailored arrivals at Miami International. Data being collected now will be used to measure the benefits and determine the viability of the procedures, as well as whether tailored arrivals will be expanded into the current air traffic control system after the trial period ends. From New York Center in Islip, New York, I'm Bill Gordon for Focus FAA.